functions. So question number 1 is, we are given f is an entire function and there exists a constant m. There exists a constant m and an r greater than 0, n greater than equals to 1 such that this holds. That is, modulus of f of z is less than equals to m times modulus of z to the power n for modulus of z greater than r. We have to show that f is a polynomial of degree at most n, that is degree of less than equals to n. Now that implies then when modulus of fz is less than equals to some constant times modulus of z to the power n. So this is the degree n, so that same degree is we are saying is here. So if f is an entire function that satisfies this inequality, then f is a polynomial of degree n. To show that, now since f is an entire function, right, so that means f is an analytic function on whole complex domain, right? Now, so therefore by proposition 3.3, which says f is an entire function, so f would have a power series expansion, and the power series expansion can be written as fz is equals to summation ak zk, where k is from 0 to infinity, and ak can be written as this, f ka kth derivative at 0 upon k factorial, right? Now, to show that f is a polynomial of degree less than equals to n, but we can show that the n plus 1th coefficient and forwards would be equals to 0, right? So what we have sufficient to prove is that f ka kth derivative is equals to 0 for k is greater than equals to n plus 1, right? So n plus 1 forward जितने भी powers आएंगे they all would be 0. Now to prove this, let r small r be greater than r and gamma t be the curve r e to the power I t, where t is from 0 to 2 pi. Then gamma is a closed rectifiable curve, right? Circle centered at 0, radius r. Now if we are finding modulus of fk0, then fk0 can be written as k factorial upon 2 pi in this. Now since around 0 kar rahe, so this can be z minus 0, so z to the power k plus 1, right? So if you are finding modulus of this would be less than equals to constant term out k factorial upon 2 pi, modulus को अंदर लेके जाएंगे, so that would be less than equals to integration over gamma modulus of fz upon z to the power k plus 1, right, and modulus of dz. Now, since r is greater than equals to r, that we have already assumed, right? So therefore modulus of gamma t would be equals to modulus of r e to the power I t, that would be equals to r only because modulus of e to the power I t is 1, right? And r is greater than r, capital R, right? So that means modulus of gamma t is greater than r. So therefore modulus of fz is less than equals to m to the power zn, where z is nothing but this r. Using the hypothesis, we were given in hypothesis that if inequality is satisfied for all z such that modulus of z is greater than r, and यहाँ पे modulus of this singular z r is greater than r, right? So therefore this inequality is satisfied where z belongs to this singular r, singular gamma, z belongs to this gamma curve, right? So on the gamma curve this inequality is satisfied, right? Now if we are evaluating this integral, that would be k factorial upon 2 pi as it is. This would be less than equals to modulus of fz की जगह we can replace by m into z to the power n, and z modulus of z to the power k plus 1 was in denominator, so that would be minus of k minus 1 in the numerator, right? So if we are evaluating this integral, this would be nothing but k factorial as it is, m as it is, m बाहर आ जाएगा, out of integral sign constant है, upon 2 pi r to the power n minus k minus 1 into integration modulus of dz over gamma, right? And dz integration over gamma would be nothing but 2 pi r, right? So evaluating this, we would have this is equals to k factorial into m upon r to the power k minus n, which tends to 0 as r tends to infinity, right? So what we have proved it. Now since k is greater than equals to n plus 1, we had to prove that this holds for n plus 1, right? N plus 1 and above. So since k is greater than equals to n plus 1, k minus n would be greater than equals to 1, and hence k minus n since greater than 1 hai, that means this would be in the denominator only. right? So therefore and hence this modulus fk0 is equals to 0 for all k is greater than equals to 1, because this was less than equals to 0 modulus wali term. Left hand side, what we are finding is that modulus of fk0 is less than equals to this term, and this term is tending to 0 as r tends to infinity, right? So the modulus is less than equals to 0, that means this term is equals to 0. Clear? So therefore fk0 is fk is 0 for k is greater than equals to n plus 1, and thus fz can be written as, since fz can be written as this power series, and for using this that n plus 1 के आगे coefficient 0 होंगे, f is a polynomial of degree less than or equal to n. Is it clear or any doubt? Next question. We are to find a function f such that f is entire, such that this f of x is equals to e to the power x for all x belongings to r. That means f की image over real line is exponential function, and we have to find such f. Now to find that f, let fz be equals to e to the power z. That is our main assumption that we can assume first hand, right? If fx is equals to e to the power x, then we can assume fz is equals to e to the power z, and let us see how we goes there. Now since fz is equals to e to the power z, then f is entire, and f of x is equals to e to the power x for x belongings to real line. Clear hai ye? Now we have to show that f is that function. Now let g be any entire function such that g of x is equals to e to the power x for x belongings to r, right? Now, and we set the set h as all those z belongings to g, the domain such that fz is equals to gz. So real line is a subset of h because f and g functions are equal on r, right? So that is identity theorem. So therefore z and 0 is a limit point of h, right? And 0 belongs to g set, right? Because g of 0 is equals to e to the power 0, x belongings to r. So by corollary 3.8, what we have is, the corollary was identity theorem corresponding. So therefore what we have is fz is equals to gz, since real line pe equal hai and limit point is belongings to the set. So therefore fz is set of all entire functions f such that fx is equals to e to the power x for all x belongings to r. So fx function क्या है हमारे पास? E to the power z. Clear? Next is question number 6, which says that let f from g to c be an analytic function and a belongings to g such that modulus of f of a is less than equals to modulus of f of z for all z belongings to g, right? So we have to show that f of a is 0 or f is constant. That means if this holds, that value at a point is less than equals to modulus, that means minimum value is attained at a point, right? So this would happen for analytic function if either f of a is 0, either this value is 0 or the function is constant, right? So now to prove this, let us assume that f be an analytic function as given, and g is a region that we know, right? So now let a belongs to g such that this inequality holds, that modulus of f of a is less than equals to modulus of f of z for all z belongings to g. Then obviously for f of a is equals to 0, f of a satisfies star. If f of a is equals to 0, either or condition hai, so first condition proof ho gayi. So we have the proof. So obviously we have the proof. So let us now assume that f of a is not equals to 0 for all a belongings to g. Then we can define gz as the function 1 upon f of z, right? So if we are defining the function gz as 1 upon f of z, clearly g is an analytic function since f of a is not equals to 0 for all a belongings to g as per our assumption, right? So therefore we can find the modulus of zz, which would be equals to 1 upon modulus of fz, and which would be less than equals to 1 upon modulus of f of a using this inequality hypothesis, right? And 1 upon modulus f of a is nothing but modulus of ga, right? So what we have is that modulus of gz is less than equals to modulus of ga for all z belongings to g, and that would imply from maximum modulus theorem that g is a constant and g is a constant, and since g was 1 upon f, so therefore f is constant. So therefore we have conditions, so either f of a was 0 or f is constant. Clear?
Yes, ma'am.
So next question we have a function, let u from C to R be harmonic function such that u of z is greater than equals to 0 for all z belonging to C. That means the codomain set is, range set is positive numbers, non-negative numbers we can say. Then we have to show that u is constant. So means any function whose domain is a complex number and whose range set is a real number, and that function is harmonic. And if we are given that this uz is greater than equals to 0, then the function should be constant. So to prove this, let us first assume that let f be an analytic function which is from C to C, right, such that uz is equals to real of f of z, right. That means f को हमने function क्या assume किया है, f is equals to u plus iota v, right. So u is equals to real of f of z, that is equals to small of uz, right. Now since u is harmonic, real of f of z is greater than equals to we are given that u is harmonic, then we can assume real of f of z uz ko, because then real of f of z is also harmonic, right. Now also we are given that uz is greater than equals to 0 in the hypothesis, right. So therefore real of f of z is greater than equals to 0 for all z belonging to C by hypothesis assumption, right. So if we are defining a function gz which is equals to e to the power minus fz, right, for all z belongings to C, then e to the power minus fz का curve would be e to the power z का curve होता है ये, right. So then g belongs to analytic function because f analytic है, exponential function analytic होता है, then g is an analytic function, first thing. Then if we are finding modulus of gz, then that would be equals to modulus of e to the power minus f, right, and that would be nothing but e to the power real of minus f of z, because minus f of z अगर minus f करेंगे, so that would be nothing but this. If हम exponential function है e to the power z, if we are finding the modulus of this function, then that is nothing but e to the power x, where z was x plus iota y, that means the real part of that component. Similarly, if we are finding the modulus of e to the power minus f, then that would be equals to e to the power minus real part of f of z, and that is nothing but e to the power minus real of f of z, and e to the power minus z would be less than equals to this 1 for all z greater than equals to C, because यहाँ पे हम क्या assume कर रहे थे, real of f of z is greater than equals to 0, right. So for greater than equals to 0, this was the curve of e to the power fz, e to the power z, e to the power minus fz would be this, right. So when this is greater than equals to 0, this exponential function is less than equals to 1, right. So therefore what we have is that modulus of gz is less than equals to 1 for all z belongings to C, right. And since, because that was given by, since real of fz is greater than equals to 0. Now what we have is यहाँ से the g is a bounded function and entire function. G entire was because f was an analytic on whole complex domain C, right, and exponential function is entire, right. So g is bounded and entire. By Liouville's theorem, g should be constant, and if g is constant, then f should be constant, because g was nothing but e to the power minus f, right. So since g is constant, this f should be constant, and hence f is constant, that means real of f is constant, that is u function is constant. Is this clear? Any doubt in this section you can ask? So next section is we have to find the index of closed curves, right. So for that we are given a function p. Yeah, p is a polynomial of degree n we are given. R is very large, so that p is not tending to 0 in this domain. That means when modulus of z is greater than r, then p is not tending to 0. Gamma t is given by this curve r e to the power it. We have to show that integration over gamma p dash upon p dz is equals to 2 pi in. right? Now, so to prove this, we are given P is a polynomial of degree n, right? So therefore, P can be written as this product of n factors, polynomial of degree n है, that means n factors होंगे, linear factors we can say z minus ak, where k is from 1 to n, right, for some constant c, and c is a constant multiple, right? So P can be written as this. Now, if we are finding the derivative of P, then P dash would be nothing but C as it is. Now, if let us see how do we find the derivative of this. The function is मान लो z minus a1 and z minus a2, right? So the derivative of this would be, if we are finding with respect to this, इसका derivative 1, so this function as it is plus this function as it is, right? So this would be summation of product from I is equals to 1 to n, where k is not equals to I, z minus al, l not equals to I के लिए, right? So this derivative function is clear of n degree polynomial. This is equals to summation from k is equals to 1 to n. Product is from I to n, l, and this z minus ak, where this l is not equals to k. Clear है? Now, then that would imply, if we are finding this integration over gamma p dash upon p, this would be nothing but, p dash is nothing but c times summation product of z minus al, where l is from 1 to n, l is not equals to k, right? And then niche p is nothing but c times product of this n factors, right? So c to c cancel first thing, and if we are evaluating this, then this would be, first if we are considering the numerator, for k is equals to 1, if we are saying, then l is not equals to 1, that means l should start from 2, so z minus a2 into z minus a3, ये factors आएंगे, जैसे यहाँ पे लिख रखा है z minus a2 upon z minus a3, right? and नीचे क्या आएगा, नीचे k is equals to 1 to n आएगा, तो z minus a1 into z minus a2 into z minus a3, right? All factors. So if we are evaluating for this, then z minus a2 से z minus a2 cancel, a3 से a3 and so on. So क्या बचेगा सिर्फ for k is equals to 1 के लिए 1 upon z minus a1, right? Similarly k is equals to 2 के लिए what we would have is 1 minus z upon a2, and similarly 1 upon z minus a n dz, right? So this would be nothing but integration over addition है, so we can separate this. So this would be integration over gamma z minus a1 dz plus integration over gamma z minus a n dz, right? Now this would be nothing but, this is the integral, basic integral जो हम कर रहे हैं. So this is index of gamma with respect to a1 into 2 pi I plus up to so on index of gamma with respect to an into 2 pi I, right? So this would be nothing but 2 pi I into summation of indexes. So this is nothing but 2 pi I into summation of indexes of gamma with respect to ai, where I is from 1 to n. Now this index of gamma with respect to ai is 1, right? For all I from 1 to n. Since gamma is a closed rectifiable curve and a1 to an does not belongs to gamma and r is sufficiently large, we are given these conditions, right? So this index is 1. So what we are having is this 2 pi I summation of 1. So that would be 2 pi I n. Clear है? So p, and this index, since index is 1, this integral sign is 2 pi I n, and p never vanishes in this. We are already given z minus z such that modulus of z greater than equals to r में p vanish नहीं कर रहा है, right? So therefore using these conditions we can say first thing that the index would be 1, and this, since index is 1, this integration size is this integration value is 2 pi I n. So we have the solution now. Any doubt? Is this section clear?
Yes.
Okay. So next section we have the Cauchy theorem and integral formula. So we are given gamma is a closed rectifiable curve in C, and A is not belonging to the curve gamma, right? So we have to show that for n greater than equals to 2, this integration 1 upon z to minus a to the power n dz is equals to 0 holds for n greater than equals to 2. Given क्या है? Gamma is a closed rectifiable curve and a is not belonging to this curve. Now since we are given gamma is closed rectifiable, that means the curve gamma is bounded, right? So therefore there will exist an r greater than 0 such that this whole curve gamma is contained in this BAR, ball centered at a, radius r, right? Since a is not contained in gamma, let us see what is having. Let us see gamma is a closed rectifiable curve. So this is gamma. A is not in the curve gamma. Let us say a is here, right? So what we are saying is, if this condition is holding, then there would exist an r greater than 0 such that this gamma would be contained in ball centered at a and radius r, right? So this radius is r. This is what we are saying geometrically, right? Now, hence, this if we are considering this region, complex plane minus BAR is an unbounded component of BAR, right? Because this ball is bounded component, right? So therefore, this whole complex domain would be an unbounded component of ball centered at a, radius r, and right. So therefore this index of gamma with respect to w is 0 for all w belongs to this region. Unbounded component के सारे points के लिए the index would be 0, right? So therefore this index of gamma with respect to w is 0 for all w belongings to this region. What we have now by corollary 5.9 is, now if G is this ball, if G is given by this ball, then f from G to C, f from G to C given by the function f of z is equals to 1 is analytic, constant function है, right? And gamma is a closed rectifiable curve in G such that this index is 0 for all w belongings to C minus G, right? Therefore for A belongings to BAR minus gamma, right? That means ball में है but not in curve gamma, right? Because ball में तो होगा because the center, and gamma में नहीं है because that was assumption, right? So therefore what we would have is, if we are finding this fn minus 1a into index of gamma with respect to a is nothing but n minus 1 factorial upon 2 pi I into integration 1 upon z minus to the power n. यहाँ पे power n है, therefore to the power n minus 1, right? Now, so for n greater than equals to 2, if we are finding for n greater than equals to 2, f function was nothing but, we have assumed function is constant function 1, so f का derivative would be 0. So for n greater than equals to 2, fn minus 1 would be first derivative and so on. So this derivative would be 0. So LHS 0, that means this integration function is 0 for n greater than equals to 2. Clear है? Next we are given is question, f is an analytic function on the disk, ball centered at 0, radius 1 on the disk, centered at 0, radius 1, and modulus of f of z is less than equals to 1 for modulus of z less than 1. We have to show that modulus of f of 0 is less than equals to 1. Given क्या है? f analytic है एक disk पे, and उस disk पे modulus of f of z is less than equals to 1 है, right? Now, so by Cauchy's estimate, since f is analytic in BAR, modulus of f of z would be less than equals to m, right? So therefore what we can have is, we are given modulus of f of z is less than equals to m, where m is equals to 1 and f is analytic, right? So about Cauchy's estimate, what we would have is modulus of f and a is less than equals to n factorial m upon r n, right? So यहाँ पे n factorial is 1, n is 1 because, right? Then m is 1, r is 1 because this ball was centered, this disc was ball centered at 0, radius 1, right? So therefore A is equals to 0, N is equals to 1, M is equals to 1, R is equals to 1. In Cauchy's estimate, what we have is this Fn 0 is less than equals to 1. This was direct question. Next we have question number 7, which is we are given a curve gamma which is 1 plus e to the power iota t. That means centered at 1, radius 1. We have to find this integration over gamma of the z upon z minus 1 to the power n dz. We have to find this integration for all n belongings to positive integers. Right? Now, first let us assume that G is the region, ball centered at 1, radius r, which is open bowl, with radius can be 1 to infinity any. Right? Now, let f the function from G to C be defined at f as z is equals to z to the power n. Polynomial function of n degree. Then f is analytic function, polynomial function hai because, right? Then by theorem 4.4, what we would have is index of gamma with respect to w is 0 for all w belongings to C minus G, since C minus G is nothing but an unbounded component of G, right? And gamma is a closed rectifiable curve. So therefore, what we would have is for A is equals to 1, if we are substituting in the Cauchy's estimates, what we would have is Cauchy formula, what we have is Fn minus 1 of A is equals to 1 if we are substituting, because the question was z upon z minus 1, right? So A is equals to 1 and power is n, so therefore n minus 1. Fn minus 1 of 1 into index is equals to this, right? Now, this would be right hand side is equals to n minus 1 factorial upon 2 pi I into integration z minus z upon z minus 1 to the power n, right? Now, left hand side is fn minus 1. We have to find f function हमारे पास क्या है, z to the power n, right? F function is z to the power n. उसका nth derivative at function 1 would be, f का nth derivative at 1 would be n factorial, right? And index is 1. So therefore this left hand side is nothing but n factorial. Left hand side is n factorial, right hand side में n minus 1 factorial. We will cancel out this. So what we have is this integral is nothing but 2 pi iota n. Clear? Any doubt? Okay, then going to next question. We have G is a region. Fn is from G to C is analytic for each n, that means for each n greater than equals to 1, this functions and Fn are analytic from G to C. And we are given that the sequence Fn converges uniformly to F and F is from G to C. We have to show that F is also analytic. That means if a sequence of analytic functions converges to a function, then the function should also be analytic, given both the functions are defined in a region, right? So therefore, to prove this, now since Fn is analytic for all n greater than equals to 1, that we are given, so therefore Fn is continuous for all n greater than equals to 1, right? So what we can do is, let T be any arbitrary triangular path in G. This is triangular, okay? So let T be any arbitrary triangular path in G. Then T is closed and rectifiable, right? Then index of T with respect to if W we are finding, where W is belonging to C minus G. G is a region, so component C minus G would be an unbounded component, right? So index would be 0, right? So therefore what we would have is, by Cauchy's theorem first version with m is equals to 1, we would have this integration over Fn is 0 for all n belongings to n. Since Fn is analytic and T is closed rectifiable with m is equals to 1, we are saying, right? Now, that means what we have is integration over T, Fn is equals to 0 for every n belongings to natural numbers. So if we are finding this integration over f of T, integration over T of f, so this would be nothing but limit n tending to infinity Fn. This equality would hold because Fn is continuous and uniformly the sequence Fn is uniformly converging to f, right? So therefore f should also continuous. So therefore that would imply, and since this limit n tending to infinity, integral f of n is equals to 0, we have proved in the previous step, right? So therefore what we have is integral over f function over the path is equals to 0. So we can apply Morera's theorem and we can get that f is analytic in G. Any doubt?
No.
Okay. So next is this section, homotopy version of Cauchy's theorem. So question number 10 we have to find this integration over dz 1 upon z square, where gamma is closed rectifiable curve in C minus plus minus iota. That means plus minus iota is not contained in the domain. Now, so this integration can be written as using the partial fractions z minus I into 2 iota minus z plus iota into 2 iota, right? Using the partial fractions we can do this from the first side. Since gamma is the curve not containing plus minus iota, this can be written as 2 pi iota into index of gamma with respect to iota, and similarly minus of 2 pi iota into index of minus iota, right? So this would be nothing but 2 pi index of gamma with respect to iota minus index of gamma with respect to minus iota. 2 pi iota bahar aayega, 2 pi iota se 2 pi iota cancel, we will be left with pi into this. Clear hai question?
Yes, ma'am.
Next we have to find this integration over gamma of e to the power z minus e to the power minus z upon z to the power 4, where gamma is this curve. We are given the curve is this. Now, for any function fz, we know that integration over gamma fz upon z minus a to the power k, if we are finding, this is nothing but f to the power k minus 1th derivative at this point a into index of gamma with respect to a into 2 pi iota upon k factorial, right? Yes, it is है. Now that means यहाँ पे index of gamma with respect to a is important. Function हमें पता है, इसके derivative we can easily find, right? यहाँ पे n क्या है? n is equals to 4 है, so derivative हमें third derivative तक निकालना है, right? And a point is 0, right? So what we have, the main point is we have to find this index of gamma with respect to a. Now, so to find this index of gamma with respect to a, what we have to use is a geometric definition of index. Now, geometric definition is how many times going through a curve around a it is wrapping up, right? So if this is the point a, right, we are starting from here. So first curve is traced by this, then क्लोज कर्व हो गया. सो रिटर्निंग टू द ओरिजिनल पोजीशन कितनी बार वाइंड अप हुआ है? एक बार. सो इंडेक्स वुड बी 1, राइट? सो देयरफॉर दिस इज इक्वल्स टू इंडेक्स ऑफ गामा with respect to 0, जो पॉइंट गिवन है, एंड इंडेक्स इज नथिंग बट 1 बिकॉज 1 टाइम्स वाइंड अप हो रहा है. सिमिलरली अगर इस क्वेश्चन के अराउंड देखेंगे, सो इस क्वेश्चन में अगर इस पॉइंट से स्टार्ट कर रहे हैं, राइट, सो दैट वुड बी फर्स्ट कर्व. जब हमने ये ट्रेस किया, एक बार वाइंड अप हो गया 0 के अराउंड, देन सेकंड टर्म ये वाला कर्व जब लेके तो ट्वाइस ऑफ वाइंड अप हो रहा है 0 के अराउंड, सो इंडेक्स वुड बी 2, राइट? Similarly, for the curve C that is given in the question, we can see that this index is wrapping 2 times. Yeah, this curve C. Right? For this, we can see that if we are starting with this point, then this would be this. Sorry, it's very large. So we can see that this winding up is only twice, right? So this with respect to this is all index is 2. Any doubt in this you can ask, or any theory question doubt you can ask about that also. No doubts?
No.